Number 1, we're asked to find the linear approximation of this function when x equals 6. So when it asks you for the linear approximation, that's just asking for the equation that can be used to approximate using the tangent line. And when x equals 6, that's going to be our point of tangency. So that's the nice x value that we can actually plug in and figure out. Later on we'll estimate a few different values. But for part A, we need a point and a slope in order to write our equation. So we know we're using x equals 6. If we put 6 into this function, we get square root of 9, which is 3. To find our slope, we have to do the derivative of our function at 6. So think of this function as 3 plus x to the 1/2. When we do the derivative, bring the 1/2 down front, subtract 1 from the exponent, and then multiply by the derivative of the inside, but the derivative of the inside is just 1. So that's our derivative. We can also think of it as 1 over 2 times the square root of 3 plus x. Well, we need to know the derivative when x is 6, because that's going to be the slope of our tangent line. So we get 1 over 2 times the square root of 9 when we put 6 in there, and that gives us a slope of 1/6. So our equation is going to be y minus 3 equals 1/6 times x minus 6. That's the equation of our tangent line. But our linear approximation has to look a little bit different. For the linear approximation, we're going to add the 3 to the other side. And instead of y equals, we're going to write this as f of x approximately equals. This gives us the equation of f of x, or an approximate value for f of x, when x is close to 6. Right, so we're going to use that in part B to estimate f of 5, f of 5.9, and f of 6.3. So let's go ahead and do that. So we want to find f of 5, what that is approximately equal to using this equation. So this is part B. F of 5.9 and f of 6.3. So we're going to find the approximations for each of these first. So all we're doing is plugging this into our linear approximation. We have 3 plus 1/6 times 5 minus 6. So 5 minus 6 is negative 1 times 1/6, so we get 3 minus 1/6. And you can write this as an improper fraction or a mixed number. 3 would be 18 over 6. So subtract that, we get 17 over 6. Or if you want to, you can write that as 2 and 5/6. F of 5.9, plug that in for x, we get 3 plus 1/6 times 5.9 minus 6. So 5.9 minus 6, we get negative 0.1, which is the same as negative 1/10. Times 1 over 6, we get negative 1 over 60. So 3 is the same as 180 over 60, so we get 179 divided by 60, or 2 and 59/60ths. And our last one, 3 plus 1/6 times 6.3 minus 6. 6.3 minus 6, we get 0.3 or 3/10 times 1/6. That'd be 3 over 60, or 1 over 20. So here we're going to get 61 over 20, or 3 and 1/20. Now the last part, part C in this problem, asks us to compare these to the real values. So let's figure out what f of 5 actually equals, f of 5.9 and f of 6.3. And if we actually put those into the function, we're going to have square root of 8, square root of 8.9, and square root of 9.3. So we're just going to go ahead and substitute those into our calculator and evaluate those. So if we do square root of 8, we get 2.828 if we round that to 3 decimal places. Let's compare that to our 17 over 6. 2.83 repeating. So that's about 5 thousandths off. Not too bad. Alright, let's look at square root of 8.9. Comes out to 2.983. Our approximation for that one was 179 divided by 60. Rounded to 3 decimal places, we get the same answer. Alright, last one, square root of 9.3. We get 3.05 if we round that. And our approximation was 61 divided by 20, which is 3.05. So you can see all those approximations are very close to the real figure.